All right, on to problem 4. By the way, I have this on the screen for a reason because the next one is actually inspired by this prank. So, number 4, as a Halloween treat, Mrs. O'Connell made 10 caramel apples to give out to trick-or-treaters. Mr. O'Connell, however, made one similar-looking caramel onion to mix in with the apples for one unfortunate trick-or-treater. This gives any trick-or-treater a 9% chance of taking the bite of the caramel-covered onion. First of all, when we approached this in class, I'm very happy to say that people really thought that I had done this. This is actually a made up scenario, but I'm very proud that you wouldn't hold it past me. Uh, so, in terms of this gives any trick or treater a 9% chance of taking a bite of the caramel covered onion, uh, that's not actually true because if you have 11 caramel covered somethings, then once one of them is selected, that 9% chance actually goes up because that there's less to take from. So I know this one's easy to criticize, but for the sake of the problem and how to respond to something kind of like this, I'm going to keep that 9% constant. Describe how you will use a random number table to conduct a simulation for how many treats the O'Connells have to give until they expect to give out the onion. So I'm going to assign 0 through, if that's 9%, to go 08 to the onion, and everything above that, so 09 to 99 to the apples. There's definitely many other ways to do this. You could, if you're using a random number generator, it might make more sense to do 1 to 9 as the onion, and then 10 to 100 as the apples, but we'd like to avoid the 3 digits if we can. Anyways, here's the table, trial 1. Here's the random integers that were generated. So I'm going to zoom in a little bit. There we go. And we're going to have to answer how many treats until the onion is taken. So we can see 15 is going to be assigned an apple. Remember, 0 to 8 is the onion. 15 would be an apple. 89 is an apple. 72 is an apple. 30 is an apple. 12 is an apple. We have to keep going until we see something lower than 8, and bingo right there. That 7 would be the onion. How many treats until the onion is taken? To 1, 2, 3, 4, 5, 6, 7, 8, 9. That 10th person was the onion. So that means there would have been 1 apple left over. Okay, next one. 58 is an apple, an apple, an apple, an apple. 2 is an onion. So that time it took 5 trick-or-treaters until they gave out the caramel-covered onion. Apple, apple, apple. This time it was quicker. 5 is an onion, and it took 4 trick-or-treaters. Some people asked, the way it's worded, how many treats until the onion is taken. If you responded differently and said 9, 4, and 3, as long as you're defending that in your wording, that's probably okay. C, state your conclusion. How many caramel-covered treats do the OCs expect to give out until someone takes the onion? Well, based on this data, 1, it took a while, and 2, we're kind of in the middle. So what would be a statistic that kind of reports that? Something like, I think here the mean is probably appropriate, which would be 10 plus 5 plus 4 is 19 over the 3 trials. Really, we should probably run more trials, but 19 over 3, I believe, is 6 1/3. So say something like so the OCs expect to give the onion to about the 6th trick-or-treater. Keywords you should definitely think about using about. the sixth trick-or-treater. Because actually, even though our mean was 6.3, it never actually happened to the sixth person. So somewhere around the sixth. It shouldn't be super early. It probably isn't super late. Around the sixth. All right. I'm thinking this might be the most viewed video ever for my channel, which means it would have to hit 4 views. Let's see how that happens.